Hello and welcome to the last video of Module 1. You are almost done, okay? So we're going to build on our knowledge of parallel and perpendicular lines from yesterday. So we are going to write equations of lines that are parallel and write equations of lines that are perpendicular. Okay, again, you've done this in algebra, but we're going to refresh it. So again, we've got our skate park railing and our skate ramp below, same one. Okay, all right. So let's do our connection to algebra. So if you remember, the equation of a line in slope-intercept form is y equals mx plus b, where m is your slope and b is the y-intercept of the line where it crosses the y-axis. So in the equation of the line containing BD, so let me highlight BD. Here's my line in green. What's the slope of the line and what's the y-intercept of the line? Okay, so the slope, if you remember, is the one next to the variable, so negative 2/3. And the y-intercept, or the b value, is 4. Okay, crosses my graph at a 4 on the y-axis. It went down 2 over 3, down 2 over 3. Okay, based on your conjectures in item 4 in the previous lesson, what would be the slope of the line containing JM? So basically, JM we know is parallel. So it's basically asking what will be the slope of the line. Use the slope formula to verify your answer or provide an explanation you use to determine it. So we're gonna do rise over run. So down 2, 1, 2, 3. It went down 2 over 3 because I did rise over run. Okay. We can also do it this way. Draw a big right triangle. Boom, boom. So that went up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's not right. The reason you just watch me struggle is because that is not a point on the grid. So don't do what I just did. Make sure your point falls nice and easily on the graph before you can do the slope. All right, identify the y-intercept of the line containing JM. So JM is in blue, crosses the y-axis up here at a 4, 5, 6. So my y-intercept is a 6. And use the slope and the y-intercept to write the equation of the line. So I would have y equals negative 2/3 from number 2 plus 6 for my y-intercept. Okay? So if JM and RJ are perpendicular, identify the slope, the y-intercept, and the equation of the line RJ. Okay? So JM is in blue, and I have the blue equation. So we're looking at RJ now. Okay. RJ is in red. So it tells me it's perpendicular. So to find the opposite reciprocal slope, it will be 3/2. So I'm going to flip my fraction, and the negative 2/3 was negative, so I'm going to have a positive number. My y-intercept, I'm going to look on my graph. Thankfully, they both actually meet at the y-intercept, so the y-intercept is the same, which is a 6. So the equation of RJ would be y equals 3/2 x plus 6. Okay? And then determine if it is perpendicular, explain your reasoning. So let's go back up to our graph. So if I wanted to physically do this slope as well, let's see, it went up 1, 2, 3, and it went over 2. So I have my slope of 3/2, and then I have negative 2/3, so I know they're perpendicular. So because the slope of RJ is, keyword is opposite reciprocal, I'm going to say is the opposite reciprocal. Because the slopes of RJ is an opposite reciprocal, then I know BD is perpendicular to RJ. Okay? So if it ever wants you to justify your reasoning for perpendicular, you're going to need to find your two slopes and then prove that they are opposite reciprocals and then drop that vocab word. Okay? move on. Guys, real quick before I move on. So this problem is not too challenging because my points cross nicely at the y-intercept, and so I'm allowed to use the slope and the y-intercept to create a nice, easy formula. Okay, it will not always be that easy. So let's take a look. Number 6. Skate park is going to have an angled grind rail. A drafter is drawn the grind rail on the coordinate plane. Okay, let's look at the connection to career. A drafter creates technical drawings of plans made by engineers and architects. Drafters primarily use computer software to make their drawings. The software position items such as lines and curves. Oh, it uses items. Cool. All right, so we got a drafter. He's drawn line N, and then the next he's going to draw line P so that it is parallel to line N going through that point. So first, if I'm trying to draw something parallel, I first need to find the slope of P. Okay, so this one might actually be easier to do our formula just because that's really, you can do it both ways. But y2 minus y1 over x2 minus x1. So I'm going to say 3 minus 1 over 8 minus negative 8. So 3 minus 1 is 2. 2 negatives make a positive to get you 16. That will reduce to 1/8. Okay, so again, you could have also drawn your right triangle and saw that it went 1 up and over 8. Both ways of doing it. Okay, so what is the equation of line P written in point slope form? So here's our formula over here. Point slope form is the most forgotten formula. I don't know why, but the formula is y minus y sub 1 is equal to m slope parentheses x minus x sub 1, where m is the slope and you have a point. So you have point slope form. So the x and the y are always going to be in your equation. This is a point, this is a point, and then this is your slope. Okay, so I'm going to take my point up here in my slope that I just found and wrote it in point slope form. So y minus, here's my x sub 1 and my y sub 1. So y minus 3. So I'll erase that down here. So y minus 3 equals your slope, 1/8, parenthesis, x will always be there, minus your x value, which is a negative 2. Okay, so if I wanted to, I could make this into a plus sign, or I could leave it, doesn't matter, but that is point slope form. Okay, now it wants me to take that point slope form and change it into slope intercept form, which looks like y equals mx plus b. To do that, you're going to distribute. Okay, so I'm going to do 1/8 times an x to get 1/8 x. 1/8 times 2. So let's say we're terrible at fractions. Multiply the numerator first. 1 times 2 is 2. 2 divided by 8 is still a fraction. So I'm going to put 2/8 or 1/4. Then I'm going to bring down y minus 3 equals. Okay, last thing I'm going to do is I need to get y by itself. So I'm going to add 3. I'm going to do it under its like term, which is 2/8. So then I just have to simplify. So y equals 1/8 x, and I would type in my calculator 2/8 plus 3. So I'm going to teach you a little shortcut. Again, fraction button is alpha, y equals, enter, 2/8 plus 3. That is times 3. 2/8 plus 3. So I get a decimal, and we like fractions in math. So to get that into a fraction, you're going to hit math, enter, enter. If you did it the shortcut way, it would probably give it to you as 13 over 4. 13 over 4. That's our answer. Okay, let me double check to make sure. Alpha y equals, enter, 2/8 plus 3. Yeah, so if you do the fraction way, it will give it to you as a fraction. If it gives it to you as a decimal, you can hit math, enter, enter. Okay, so that is the equation of our line that would be parallel to it. Now, if you remember, back to algebra, I can't graph a line that has a fraction on a y-intercept. I just can't physically start on the y-intercept to graph it. So we're going to have to get creative. So my slope is 1/8, and I have a point. So to do that, you're first going to graph your point. So -2, 3. All right. So then you would do your slope. So my slope is up 1/8. So I'm going to go up 1/8. 1, 2, 3. Okay. So you can create a line if it has a y-intercept as a fraction, if you've got a point and you have the slope. So I'm going to go ahead and draw green. We'll go green. If I extend that. All right, so there is our parallel line. Cool? All right, so that introduced you to creating a line that is parallel, same slope, through a point. You use the formula, point slope formula, and then it teaches you how to distribute to create the equation of it, and then graph it. Okay, moving on. All right, the drafter needs another line. He needs line Q so that it is perpendicular to line N going through this point. So let me go back and figure out what line N's slope was. So we found the slope of this was 1/8. Okay, so I'm going to write that. All right, we're going perpendicular to that. So perpendicular means opposite reciprocal. So that means my slope is going to be -8/1 or -8 because it has to be an opposite reciprocal. It's a terrible line. Okay? So remember, opposite, flip it, change the sign. So now what would be the equation of line Q written in point slope form? So my formula for point slope, I'm going to rewrite it. Y minus y1 equals m times x minus x1. Okay? So I'm going to take my new slope, which is perpendicular, and then my point from up here. So y minus 7 equals my slope, -8. I'm going to get rid of the fraction. Parentheses x minus my x point, which is a -9. Okay? Again, I can leave it, or if I wanted to go ahead and make that a plus, you could. So now I'm going to write it in slope-intercept form, which means I'm going to distribute. So distribute, you get -8x minus 72, bring down y minus 7. Okay, so now to get y by itself, I'm going to add 7 to both sides. So y is going to equal -8x minus 65. Okay, so again, this is a process of how to write the equation of a line. They're going to ask you parallel, perpendicular. You'll have to know if you keep the slope or make it an opposite reciprocal. If they give you a point, you're going to use point slope form. To write it in slope-intercept form, you're going to distribute. Then it wants me to sketch this on the graph of the original one. Now you will also know I cannot graph something that is a -65 on the y-intercept. Just can't do it. So I'm going to do the same thing. I'm going to use my slope of a -8 and use this -9/7 point to graph it. So let's go back. My point is -9 and then a +7. Okay, there's my point. Now I need to do my slope. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Okay, and then if you connect those lines, it'll give you a good picture. So it doesn't necessarily touch at that point, but we just know that it has to be perpendicular because the slope of this was -8 and the slope of that was 1/8. So let me go ahead and add some letters. This was line P, and this was line Q, so we don't get confused. Okay? All right, so we got line Q, which is perpendicular to both of them, and then we're going to move on. All right, so let me know if you have any questions on that. I'm actually going to let y'all try one now. So y'all are going to try E. So So the last line would be line R. You're going to draw me a line that is perpendicular to N, passing through the point 8, 0. So see if you can write it in point slope form, slope intercept form, and then graph the final line. Okay, so very similar to what we just did. Press pause, try that one. All right, so if it's perpendicular to N, which was 1/8, you need to use the slope of -8. And don't be freaked out by the 0, just still goes there. Once you distribute it out, your final answer will be -8 plus 64. Okay, so if you'll remember, I cannot graph that on my grid, way off the graph. So this one might have given you a little trouble, so I'm going to walk you through it. So my slope is -8 going through an 8, 0. So I graphed the point 8, 0. Now you'll notice I can't go down 8 on my graph and over 1. If I did, it would be somewhere over here. Okay, so the opposite of going down 8 and over 1 is to go up 8 and left. So you may have to do the opposite. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Okay, so that would be our line. I'm going to draw a rough sketch. Whoop, that's a terrible line. And that is my line R. Okay, so make sure your line wasn't facing the other way. You can't go up and right, you would have to go up and left. All right, so you've drawn 4 lines now, so let's compare them all. So I gave us a little shortcut. Here's the answer. All right, I want you to try number 9 and number 10. So number 9 says, reason abstractly, quantitatively. Describe the relationships among the lines N, P, Q, and R. So if you'll remember, P had a slope of 1/8, N had a slope of 1/8, Q had a slope of -8, same thing, R had a slope of -8. So I want you to tell me what you know about the relationships of those lines, and then try number 10. Press pause. Right, I was able to tell a lot from this picture. So I know N and P are both parallel to each other, and then I know Q and R are also parallel to each other. Then I had a lot of perpendicular lines going on. So N, my black line, was parallel to both perpendicular, to both Q and R. And then my other parallel line is also perpendicular. So P was perpendicular to Q and P was perpendicular to R. Okay? All right. And last but not least, number 10 was a rectangle. Maybe you said square, but again, a rectangle is the shape in which you've got perpendicular lines and parallel lines to create right angles. Okay. All right. So that is the lesson. That was kind of a lot. Writing equations of a line is kind of nitpicky and it's a lot of work. So we've seen 4 examples. But I want you guys to try some more. So try 11, 12, 13, 14, and 15. Okay? 11 and 12 aren't too bad. Number 13 gives you a lot of things. It gives you 4 lines, and you're going to compare them. And to compare them, you first need to find their slope. Okay? So this one gives it to us. You got to do a little bit of work to find your slope here and here. And then D, I'm going to go ahead and do it with y'all because I think we probably forgot. So how to find the slope of a line that looks like this. So -5x plus 3y equals 6. I want to put this in slope-intercept form to get y by itself. So I'm going to get rid of the 5x and plus 5x to both sides. That leaves you with 3y is equal to. Now I can't combine the 6 and the 5x, so I'm going to rewrite them. I'm going to rewrite my slope first, plus 6x. So I just moved my x to the right side. Then I'm going to get rid of the 3, dividing it by every single term to get rid of it. Okay? So the final equation in slope-intercept form of this line would be y equals 5/3 x, and then 6 divided by 3 is 2. Okay? So that is a skill from algebra. That is super important. It's on the ACT a ton. Like all this stuff is all over the ACT. Okay? So now that should give you a hint on 13. And now you can draw the rest. So press pause And then we'll go over our answers and be done with Module 1. Answers! So number 11 was 4/5. It wanted parallel, so we just had to copy the slope down again. Number 12, it wanted perpendicular to -2. So you can always put something over 1. So if I flip that fraction, I get a positive 1/2. On 13, the slope of A was 3/5. The slope of B was -5/3. I did it in here in blue. Slope of C was 3/5. Did it in the green. And we did that together. D was 5/3. So based on these numbers, I know A is perpendicular to B, and I know C is perpendicular to B because they're opposite reciprocals. I know A and C are parallel. And then I know D isn't parallel or perpendicular to either A, B, or C. Okay? Shout out to y'all if you got that one. That was a lot of work. All right, number 14. Wanted to know the slope of the line y equals 3. So remember, y equals, I think it was -3. -3. It's going to be a horizontal line hitting the y-axis at a -3. So the slope of a horizontal line is 0. Okay? So that was the first part. And then if it is a vertical line, that will be undefined slope. Okay, so perpendicular would have undefined, meaning x equal to number, like x equals 2, etc. And number 15, you would first find the slope of the given line. If you're finding the parallel line, you're going to keep the same slope. Then you will use the slope in the point to write it in point-slope form, and then distribute to get it in slope-intercept form. So 15 just wanted to give me a step-by-step process of what you would do. Okay, so 1, find the slope. 2, keep the slope. 3, write the equation in point-slope form. 4, distribute it out. Okay? All right, you have done a great job. This lesson was long and not fun. I apologize. And a lot of graphing. So if you're at home on a computer, wah. All right, thanks for watching. You can now practice, and congrats on being done with Module 1. I don't know how to exit this video.